This next example of a process of solving a quadratic equation is called completing the square. And this is something that will be very important for those of you going on and taking more calculus. So make sure that you understand this process, even though we don't use it that often because we have, for example, the quadratic formula, which kind of lets us avoid it. But we have to understand how it works. And it's really based on a product that we've already seen. We know that x squared plus or minus 2bx plus b squared factors as x plus or minus b, the quantity squared. These signs will match the sign here. Okay, that's just one of our special products, and we usually use it in reverse when we multiply out, but remember the middle term is 2b times x. For example, if I just do x minus 3 squared, quickly, what do I get? X squared minus 2 times 3 times x and plus 3 squared. Now if I think of reversing that process and going backwards, notice what that middle term looks like. It's 2 times the coefficient that is squared and added. And that coefficient in turn goes right here in the factoring. Okay? Completing the square starts out with the first two of those terms, adds the third term that will allow you to write it in factored form. And so that's what completing the square does. Let's see how it works. Now, this process requires that coefficient to be 1. So our first step is to make sure when we're completing the square that we have a 1 on as the first coefficient. If not, we have to divide each term by that number. Then we'll move the constant over to the right side of the equation. That'll just make life easier. And then we're going to complete the square by looking at the process that we did here. You take whatever the middle term is that you have, divide by 2, because notice it was half. This was 6x. It was half of that that we square and add to get a quantity which we can then factor as a perfect square. And once we have the left-hand side as a perfect square, then we can use the process that we saw in the previous example, use the square root principle. Okay, and again, this is important. We are going to expect you to be able to complete the square. So you want to be sure and get lots of practice and understand what's happening as you do the completing the square. Okay, so let's look at this example. First of all, I see that I have a 3. So I have to eliminate that, so I divide each term by 3. And again, to maintain consistency and an equivalent equation, I have to divide each term by 3. And notice since I have 0 on one side, that's just going to stay as 0. So it'll be x squared minus 4/3 x minus 2/3 equals 0. And so I get x squared minus 4/3 x equals 2/3. Okay, everyone with me on that? Now, notice I left a space here because I want to figure out what do I need to add to complete the square. And remember, if I add it to one side, I'll have to add it to both. So how do I determine what to add? I go back to our process. Remember, the middle term is twice what you add and then square. So let's see how that works. We look at the middle coefficient, the coefficient of the x term, and it's 4/3, and we take half of that. And it's a simple multiplication of fractions, and it's just going to be 2/3. So that is what I'm going to add. So I am going to then add 2/3 squared. And I have to add it to both sides. Okay? You see how that works? I take half of the middle coefficient, square it, and that's what I add to both sides. And notice it's always addition. Okay, so now I have the equivalent equation and I forgot to multiply that by x. Okay, now why did I do that? Because the left-hand side will factor. And to emphasize that, I'm going to just take the square root of 4/9. And I see that if I'll have 2/3 and another 2/3, I'll have 4/3 x. So it works. And this is going to be 2/3. I'll need to multiply by 3. And I have done exactly what I wanted. Now I've written the left-hand side as a perfect square. And the right-hand side will be what? That's 6/9 plus 4/9. Okay, so that'll be 10/9. And that equation we can solve by extracting roots, taking the square root of both sides. Okay, is everyone clear on that? Please take time to review that and understand where that term came from, that 2/3 that we then squared and added to both sides. That's the key step. That's the step that actually completes the square so that I can factor. Okay, so now we're ready to actually solve the equation, and we know how to do that because we extract the roots. We take the square root of the left-hand side, and remember it's plus or minus the square root of the right-hand side. Okay, so that tells me that x equals 2/3 plus or minus, and if I reduce that, that's just the square root of 10/3. So x equals 2 plus or minus the square root of 10/3. And that again, remember, that does mean that there are two solutions. X equals 2 plus the square root of 10/3, or x equals 2 minus the square root of 10/3. Okay, and some of your web assigned problems I know are going to ask you to split it up like that and actually get a decimal equivalent. So that's why I wanted to show you. But if you're just asking for the solution, we'd be perfectly happy with the plus or minus notation, simplifying that. Thank you. That's a hard one to completing the square always gives students difficulty, so make sure you spend some time understanding this example.